Welcome you all. Today we'll just understand the importance of shafts, importance of groove, and some of the best practice while designing project 3D elements. What is the importance of shell out edges? And followed with one exercise where you can able to read the drawing and understand the importance of reference elements. And that reference elements will give you more insight how a design is best fit. And more on that, we will spend some time in reading the drawing, understand the drawing reading, and then move on further so that your modeling capabilities is done based on the drawing reading what you are going to do it. Let's quickly get into our session today. So the first thing for the today's session, we are going to just cover some of the important features, which is nothing but your shaft, right? And your groove, and followed with what is the importance of the project 3D elements, which is nothing but your shell out edges. Let's get quickly into that one. What is shaft? A shaft is a format where you can able to create any cylindrical components where you have an axis system, and with reference to that axis system you can able to create the geometry, 3D geometry, where I can able to create my shaft, a revolved shaft, something like a revolve with reference to an axis where you can create a symmetrical cylindrical components. So there is some of the ground rules and some of the processes which you need to understand while using this shaft. The difference between a shaft and a groove is that the shaft is a material addition process, groove is a material removal process. That's the only difference, right? So let's get into this one. The first ground rule, what I would like to tell you is the moment you go for a sketch and give it OK, if your profile, whatever you're going to create it should have a closed profile. It's not mandatory that it should have a closed profile, but you need to have an axis system with which I'm going to rotate my entire cylindrical components. So in this case, for instance, I'm going to just draw my profile. Say this case, this is my profile which I'm going to draw it, right? Then I'm going to have my tangent arc. Then I can create my point. Then I can able to create my line. So that I can just create any profile of any dimensions. And provided always, it's very important that your endpoint just closes with your axis system. That means at this point, if you see this one, my component, whatever I would like to design it, is going to restrict my shaft with reference to this vertical axis. And now if you exit this workbench, it's not mandatory that you need to close the sketch by point, but this point needs to have an endpoint with an axis system, and this point also should have an endpoint with this axis system. So now you can able to shaft this component, this profile, with reference to this particular axis, right? So that means this is my profile and this is my axis with which I'm going to rotate it. So it's fine, you get your component, right? That means while designing it, a shaft command, it's not mandatory always that this has to be closed, but for the requirement, if any point of time this particular sketch, see this, is not coincide with this axis of rotation, you will have an error message. That means this is not possible. So this gets what is the message? The selected sketch has to be closed or closed by an axis system. We don't have it. So that's the reason that in this particular case, the sketch of the profile which you're going to create is not going to have it. So that means always your endpoint needs to be get connected with an axis system which we are going to rotate. So that means what are the possibilities of creating this profile? So one way, is this possible to create a shaft? Yes, this is possible. No way the shaft will be created. See that it's possible. Is it possible this way? Yeah, I'm going to just take it, and this sketch I just removed it. This is also possible. Fine. Is this way possible? I'm just going to have the sketch and I'm going to just exceed this sketch a bit more, and rotation axis there, you'll have an error. This is also not possible. So always the sketch, whatever you just created, it should have a profile which needs to be seen. This is not possible. And if at all you would have a profile something like this, and I have a profile something like this, and you have a line which join this one, right? This one and this one. I just join this one. And now when I remove it, or when I rotate this one with reference to this axis, you can see that the result, it is possible. So this is also possible. That means you create some sort of a tapered hole based on the dimension whatever we give. So this is also possible. So that means when you start creating your feature, there are different ways where you can able to understand the sketches. Are you guys clear? Please let me know. Are you following? Just message me. Perfect. So now let's get into one of the understandings. So that means always when you go for a sketch, the first thing is that you need to have an axis system. So default, you just draw this axis. This very powerful tool where this axis system can use it. And this axis system I can start dimensioning with reference to this one. So this is very powerful tool. I'm going to rotate with reference to this axis tool. So let's quickly get into one of the example and understand about how to design this component feature. So let's go close this one. Right. So I'm going to open a file and use this exercise quickly. In this process, I'm going to give you an idea about the best practice of the design and how you need to dimension your features always. So this sketch is done. Let us go and check whether the sketch is fully constrained for my component to get accessed with reference to one rotation axis. So in this case, what I'm going to do is that I'm going to just take this sketch and ensure that the sketch is fully constrained. So let me know the sketch is fully constrained or not. Perfect. It is. But do you find any mistakes in the geometry or dimension representing? That means, is there any challenge? I'm going to rotate it. See that I'm going to shaft the entire component with reference to this axis, right? This vertical axis. So this is my shaft, this is my profile, and I'm going to rotate with reference to this axis. This is my rotation axis. So I can ask the axis, and you can just rotate with reference to that one. It happens. There is no problem. But what is my challenge? I would like to tell you is that there is small mistake, or not a mistake, a representation of a drawing symbol or the dimension is not correct. So if you see this component, this one, right, this one, this value, whatever I'm going to represent, this one as well as this one is radius. You need to have in front of it radius 25, right? It's not length 25. Here also it is radius of 50, not length of 50. There is a difference between a length notification and a radius notification. As engineers, you need to be very careful. And here also, the dimensions and the geometries, how it is represented, should be possible. That should be very taken care. That means in this our case, just to see an example, that I'm going to just draw an axis system because I would like to mention this one dimension in terms of radius. That means when I just click on my deleted this dimension geometry and just select this one, the constraint, dimension constraint, and select this one and this axis, right click, you can't see this one. This is the dimension which we saw earlier. But for us, in this case, I would like to represent this one in terms of radius, 50 radius, 25 radius, and 20 radius. So what to do that one? So that is the purpose of this axis system. So I'm going to delete all this one. See this? I'm going to delete this one as well. And I'm going to delete this one as well. And I'm going to just draw an axis system. See this? And that axis system has to be constrained. See this? Put it normal view. and make it this constraint. That axis is constrained. Now we can just see this. Now what I would like to represent is that this is a cylindrical component which I'm going to shaft, as you saw that. Select this one and select this axis. Select this one and select this axis. Select this one and this one. Right click and see that you can see this radius. And in this case, this is my radius, right? Just double click on it and represent this radius. So this is the way in which you need to represent the geometries, even in Sketcher also. And similarly, I'm going to select this one, this line and this axis. This axis, right click, you get radius. Only when you have, very important, only when you have axis system, then only you can have this radius or diameter. If you use the vertical axis system, you will not get it, right? Only this axis system is useful for you to give this one, right? So that means I'm going to select this point and this one with reference to this one, axis, right click and go with the radius, right? Just double click on it and give with the radius value. So this indicates that you're giving a radius value. That means always understand that when you start creating any of the axis system and cylindrical component, the representation of your geometry, the dimension, very, very important. So you will tell, what is the difference, Bernard? It's 25 length, radius 25 fine. It's no problem. But yes, as a person, when you take this component into generative drafting, that time it represents that this is a radius. If this is not radius, right? If it is length 25, idle, it's just a block. It's not a cylindrical complex. Now, the moment I just made this one as a 25, R20, R20, I mean to say that I'm going to rotate with reference to that axis. The moment you go and rotate this with reference to axis, so you get your shaft. So I'm going to rotate with reference to this, component with reference to this axis. So you get that. Automatically you get selected axis. Are you guys with me? Please let me know. Apti, Ajay, Ankush. Yeah, thank you. Perfect. So now our next objective is that I would like to create, in this case, a group. I would like to create a group. To create a group, what I'm going to do, see this, I'm going to just create a sketch and I'm going to create a profile on that one. Just give it OK. So in this case, you need to tell me whether my design is correct or not. I'm going to give you a task now to understand the design process. So I'm going to just draw my rectangle at this point, right? And I'm going to just draw an axis system, right? And I'm going to just mention this one from here to here, radius, right? I'm going to make it as 50, right? And that is also done. And then I'm going to just dimension from this particular line, right? This from here to here, that is a distance of 100 mm and 100 mm, and the dimension of this one is 10 mm and this dimension as well as 10 mm, right? I'm just doing this one. So I just created my sketch fully constrained, right? And now using this profile which is fully constrained, I would like to create a group. See this, I'm going to create a group. So this is my pad which this is my shaft which we created. Now using this rectangular component, I'm going to use my group. So this is my sketch which I would like to group it and just give it OK, fine. We have this group. Okay, so now we just did a shaft and a group. Are you convinced whether my practice is better, the design process or the design approach is correct? Fine, it should be good for the current position or current scenario. I'm asking Mr. Ajay that, Mr. Ajay, can you just change the shaft diameter from 50 mm to 55 mm? or 60 mm, for instance. So in this case, what I'm going to do is, I'm just going to change my shaft diameter from 50 mm to, I'm just going to change it to 60 mm and just give OK. What happened to my groove? The groove is not appearing over here. That means there is a challenge for me. So let's go and check what is happening inside this one. Just go there and check this one and check on this plane. See that the groove is lying inside. That means our design is not meeting the requirement, right? So that's a problem, that's a challenge. That means always we understand that the design, whatever we created currently, down the line when we do a modification, that modification should meet the current requirement or the design change. What we did, we just did only two feature. Within this two feature itself, there should not be any ambiguity over the period time, the modification time. So that's a design process. The design process always tells that the moment you start designing it, you need to not think only for the current scenario. You need to think for the future requirements. The future requirement is something where you need to identify, if I do any changes, small changes, what's going to happen. So in this case, it's okay, fine. Then I'm going to change this one to 45 mm. What happens now? You just see. The groove will be appeared. Just go and check this groove. Or check the sketch. You will understand first. In this sketch, see this, it's lying there space, which is not mandatory, which is not required. So my objective at this moment is that, okay, fine, my first for the current situation it was okay, for 50 mm it was okay. But we are all in the toughest world of engineering change management. Every day they keep changing happens, right? So the moment I change this diameter, you're not able to see the slot or the groove. Sorry, in this case it's groove. So our design approach has to change. What is the biggest challenge or the best practice is avoid such dimensions at this point. Which dimensions? This is the point which is making my design a challenge. Avoid that one. To avoid that one, what we need to do, this dimension itself is not required for me. Okay, let's go back and give this change to exchange. So I'm going to just change this sketch to 50 mm itself. 50 mm. And exit this one, you get this. See the groove. Now go to the sketch. Now we are going to learn something new. Projecting your 3D elements. I'm going to use projecting your 3D elements. Just see here. In the operations, right? You have, I'm just going to make this one. And I'm going to just make project 3D elements. In this project 3D elements, we are going to learn something very interesting called as project your 3D shell out edges. Project your 3D shell out edges. That means this particular cylinder face which you're having, it doesn't have a feature. It doesn't have an edge. Until unless you don't have an edge, how can you project it? Because it's a cylindrical face. So for that, we have something called projecting your shell out edges. The shell out edges is something which I'm going to use it in this case. So for that, what I'm going to do is that go to the sketch which we did it, right? The same sketch. I'm going to modify certain things. See this, and put it normal view. And now, what I'm going to do in this case is this, that I'm going to delete this one. I'm going to delete this radius. So obviously, you can see this is case, and I'm going to don't want this line as well. This line. I would like to use the edge or this face of this one as my edge, right? So what I'm going to use, see this, I'm going to select my shell out edges. This is my shell out edges. So select this one, and you see that this operations may subjected to algorithmic instability. You should reconsider your design. So that means you need to reconsider your design. That means I'm just going to give OK. And let's see that when the moment I selected, you can see an yellow line which got projected. And this line also got projected, right? I don't want this line, so I'm going to convert into construction element. Just right. So I can just use that one into construction element. At the same time, at the same time, I would like to make this line delete. So just put it normal view, and I would like to make that this particular line, whichever I just have it, I'm going to quick delete this one. So I'm going to delete this one, and I'm going to delete this one as well. So see this, Control Z, I have this one, so just move this one. Any dimensions, I'm going to quick trim this one. So construction element off it, and just quick trim this one. And I want to quick trim this bottom side as well. And then what you do, you just constrain this point. See this point with reference to this point. Just constrain this. Give it, fix it. Sorry. I'm just going to constrain this one. Cancel it. I'm going to just constrain this one. See this. So take this end point and constrain this point. You will have the challenge. That's the reason I'm just teaching you how you will do a mistakes. So I just made this coincident. Give OK. You did this. And similarly, you just take this point and ensure that this particular point are also constrained, coincident. And this dimension, I'm going to use it for the dimension of this one. This between this one and this one. Sorry. Between this dimension. Select it. I'm going to use this dimension. So select this one. And I'm going to give this one as 10. Right? So this is my component. So now what we do, let's go and check for a sketch analysis. What if you learn it? So go to my tools, go for sketch analysis. Is the sketch? Yes, perfect, closed. And there is no radius playing a role. Always what is happening in this case is that my sketch is always constrained with reference to this. Make a show of this one. Just double click on the sketch and see that always the yellow line indicates. Now make a note of it, that the yellow line indicates that it is projected elements. It is having some external references of that. What is the external reference? Nothing but the surface face. So now the moment you just create it, normal view, your sketch is fully constrained, and now your groove is done. And now you go and do any changes on this, hide it, and do any changes with beat. You're going to give this dimension from 50 to 60. Exit this one. You can see that the groove is going to follow. That means, just observe this. Always the sketch is going to follow this one. So that's the purpose of you to understand. Right? So now in this case, let's get into this one. Exit this one. Whatever the dimensions you keep changing on this groove. Say for example, I just changed here from 60 to 45. Earlier it was a challenge, right? Now always the groove will be following, and this groove will not change its cross section as well. See this? It follows. So this is the purpose of the best design practice. The design is best when it is modifiable and doesn't affect when you do set changes. And that's the process which you need to understand. That in this case, we use the shell out edges, where the shell out edges is used typically to make these edges visible now. Let's get into this one, next level. So now we have done this groove. So I'm going to select this project, plane, go for sketch. And on this plane, I'm going to create a profile. So for example, I'm going to just draw a rectangle on this one. And I'm going to just make this profile. See this one, and this one. With the reference to this vertical axis, make it symmetry. So this one. So make it symmetry. I got symmetry. And from base, this distance from here to here, right? The distance is 100 mm. And then, so 85 mm. Just going to make it as 85, right? And this particular dimension, see this? I'm going to just make this dimension as 40. Sorry, I'm going to make it as 40. Okay, and then I'm going to make this one. So this dimension to 20. I just created this one. So just create, I just made this profile, and by mistake, see, I just created this profile here, but I would like to do this profile on another plane. So this plane is here. Say for example, I'm going to create a plane. I just created this plane and I'm going to make a offset plane from here 42 mm for example. But this profile we have made in this one, this profile is supposed to lie on this plane one. That is the requirement. So no need to worry. Go to the set sketch and just go there, change my sketch support. From where? From YZ plane to this particular plane. So the moment you select it, it moves there. See this. So we understood how to change your sketch support as well. Right now we did this. So now you just go for pocket, and I'm just going to pocket this one, this profile, the other side, reverse side, for a dimension of reverse side for a dimension of 15 mm. I'm just giving 10 mm. So that I just created. So similar, this pocket I would like to create the other side as well. I just created this one. So this is something. Still you would like to give this feature less, so I'm just going to change this value to 8 mm. Right? Or give to 5 mm. So I just created this feature. So this one, I'm just going to make this change, change the value to 5 mm. Something like this. So that means I just created a groove on this one and I just created a cut for 5 mm. Just use this one. I'm going to teach you something called transformation features, in which I'm going to make a symmetry of this one. So I'm going to make my mirror of this pocket with reference to this particular plane. Yep, with reference to this particular plane. Give OK, you get this pocket as well. So we just created this pocket. Okay, so that means in this case, what we did, we understood that how to create your mirror, how to create your pocket, how to change my sketch support. So you just see that this is my plane challenges. I would like to move further. Let's your pocket also get changed. I would like to increase it. So you can just see this one. So I would like to make this one design as per this one. See, just change the plane. The moment I change the plane, your pocket also gets changed. So in this process of learning, what you understand, the importance of project 3D elements, the importance of groove, the importance of shaft, and the importance of pocket, and the importance of plane and the mirrors. Okay. Welcome back. Now we'll just understand how to perform the drawing reading, and whatever we learned, understand that one, and then proceed for creating the feature, the same feature. Let's go and learn this. I'm going to use this component, a drawing, where you can see this drawing. First, read this drawing. What are the dimensions you are going to use it in this case? So I'm going to just zoom this one, and first understand this one. So if at all you would like to take it, a point of information is just take it as dimensions. So the first thing, when you want to read the drawing, read the basic things. Front view. This is my front view. Then, after that, there is a section view called AA. That means I'm going to section this one and view from here. The moment you view from here, you can able to see these components, right? So that's a point. And in this case, there are different geometry, and this is a cylindrical component once again. So that means when you section this, you can able to see this hatching, right? This is my hatching, where I will create this hatching and just want to give you some difference. So properties, I'm just giving the patterns of 2 mm. So you can see this hatching, section view. So this is my section. So I'm going to use this section view and start creating the feature. So let us read this drawing first. There is a geometry which is nothing but 28 inside, and this is my bit circle diameter, which is nothing but 56. And then I'm having this hole which is at a distance of 7 mm from the top face. Here there is a hole which can be created, and there is one more 18 mm, the distance of this one, and the whole diameter of this one is 5 mm, and there are 4 such bolts, 1 2 3 4 4 such bolts, a counter bore drill, a counter bore, which I'm going to use it at each and every location, and this hole is positioned at an angle of 30 degrees. That is the things which you need to understand. So drawing reading is so important. So first thing, understand which you are going to use it as a absolute axis system. So this is my front view, right? So that means this becomes isometric view. You need to select this is my front view. On that particular front view, you need to create its dimensions. So this is my 76 is the longest dimension, 38 you are having, so then you have 28, and one more dimension of this one is missing, so probably I think I might have deleted. This is 38, this is 28, and this dimension. Okay, no problem. 76, 38, and this dimension. Let's me take it this dimension as well. So I'm going to take this dimension from here to here. So this dimension is missing. Okay, 48. So this is my dimension which I would like to create now. And this particular geometry is also there. So this geometry is 28. You know that. This is my 28. And this one is 48. Okay. So let's go and perform this one. So to do this one, the first thing, I'm going to just make this cross section first. This cross section. Right? And this 16 mm, 18 mm, 26 mm, all this profile I'm going to take. And what is the distance from here to here? 76. Let's go and start this one. So first, go to this profile, file, and go to my new part, keep OK, and just create this feature. So I'm going to click on my sketch, go for sketch. So this is my front view. See this? This is my front view, right? And I would like to create the cross section there. So that means I would like to create my cross section. So this is my selection of your axis system. So in this case, I'm going to select this one. So this becomes your horizontal and this becomes your vertical. So just give OK, fine. You get this profile. So now I'm going to give the cross section of the geometry. So let's go and do this one. So first, I like to draw my axis system because I would like to give all the cross section of the dimensions, right? So this is my dimensions which I'm going to draw it. So this is my first cross section which I'm going to use in this case. So this profile, right? So let's go back to my part model. So then I'm going to just create this feature. So first thing I'm going to just draw is, see, from here to here, what is the distance? 76. So hardly you just draw to the nearest value. And this is my profile. So I'm just drawing this profile. Just see this profile once again. Right? So this profile, I'm going to draw only this profile. Right? Let's go there. See this? I just draw this one. And just from here, I'm going to take this profile. Just draw this profile. Yeah, see this, I'm just drawing this profile to the nearest value. Just close this one. Just zoom this one. First, I'm going to fix my longest dimensions, everything. So the purpose of me drawing the axis is that I would like to create all the geometry from here to here. See, from here to here. What is the dimension? Radius. I'll fix this one. Okay, see, it's more. Then I'm going to fix from here to here. From here to here. Radius. I'm just fixing everything. So it's more, right? From here to here. It was 48. Just right click. Radius. Just 90. It's too heavy, right? So just go there. The dimension is too large. Right click. Give here. This is also 25. So first, I just then fix all this dimension, and this dimension, all this dimension, whichever I would like to prefer it. So these are my first level of feature of dimension. So 25, 28, and then this dimension. See, this is 16, 18, and this is 26. So I'm going to fix that one as well. Go there and go to my part model. and I'm going to take this one, and from here to here it is 26. So this is my first level of dimension. So first I'm going to fix all this one. This is my 26, and this is my 18, and this is my 16. See this first. Then I'm going to fix here. This is my 28, right? And this is my 38, and this is my 48, and this is my 76. So I just did this cross section. So simple way. I just manage all the profile and just draw with reference to that axis. So this is my cross section, which we saw here, right? The same cross section which I draw in my one of the plane. So the same cross section, we just do this one. So 18, 26, 16, 38, 76, 48, and you have 28 as well, right? So now let's get into our process of next level of step process. In this case, I'm going to create exit this one, and I'm going to rotate with reference to this axis. You know that, shaft it with reference to this axis, so that you get this one. So this is my front view. That's the reason. The moment I just created this, my front view. So that's the reason my selection of my sketch also was in this particular planes. Right? See this. Exit this one, you get this profile. So you have this profile. Now the next step for us is, I would like to create your fillets inside. This fillets you can give here as well. So I'm going to create this fillet for a dimension of 2 mm inside, which is there. I just created that one as well. My next objective is that I would like to create a hole which is at a distance of 7 mm from this particular top face at an angle of 30 degree. All the stuff I'm going to create. Now, this is my drawing. Just let's go and understand the drawing better. From this top face, the whole distance is at a distance of 7 mm. So I'm going to just create this profile. That means I would like to create this center point of the hole, which is nothing but from here 7 distance from the top face. So best practice, what is the process? You have different approaches, but in this case I'm going to teach you one of the best practices, that I'm going to use some of the reference elements. So I'm going to create a reference element. So I'm going to create a plane, and on that plane I'm going to draw my profile. See this, I'm going to select my plane first with reference to this particular plane. See that, reverse direction at a distance of 7 mm. I'm just creating 7 mm, a plane. Okay, this is done. So the moment I just created this plane, on that particular plane I'm going to draw my sketch. See this, this is my plane which is offsetted at a distance of 7 mm. Cancel it. And now on that particular plane I'm going to create my sketch. See this, on that plane I'm going to create my sketch, and this becomes horizontal, right? See this, if somebody was asking me, is it required? Yes, it's required. I'm making this one as horizontal. The moment I make this one as horizontal, you can see that it pops in for you, this face, right? And then I'm going to just draw from here an axis system. So from this particular center point, I'm going to draw an axis system first. And this axis system for me from here to here is 30 degree as per the inputs. Sorry, this dimension is 30 degree. I just drew this one as well, right? And on this particular plane, I'm going to just draw a profile. See, this is my rectangle profile. Just draw this one and just make this one. You get this one as well, right? So you know the dimension which I'm going to give right from here to here. This axis. See the importance of axis system, right? Like, and give this one, this axis system. The radius diameter is 5 mm. Just do this one as well. And right click. Anyhow, I can just make this one fix line. I'm going to fix this one. or you can just make the dimension as well. You know the dimension, you can just make this one. So I'm going to make this dimension from here to this one. So I'm just going to make it as 45, and similarly I'm going to make this dimension from here to here as 10 mm. Sorry, as 10 mm. So what we did, we just created a profile. This diameter is 5 mm, so it should be diameter, yeah, correct. We are supposed to create a diameter frame, not. So if at all you want to give in terms of radius, you just change the dimension to radius, so that's possible. Exit this one, you get this one. So your profile is available now. So now we learned how to give groove, right? The same groove, I'm going to use it here as well. So now your groove is also done, right? So this point, you understand that this particular plane on which we did this sketch and made a groove is also done. So now, isometric view, I have it. Now my objective is to make the holes, right? So for that, what I'm going to teach you first, understand that I'm going to create my hole on the top face, and I'm going to create position in sketch. Very important to understand this position sketch. And on this position sketch, I'm going to use the profile. So first thing, I just make this one coincide with this one, right? With that, this axis, number 1, so that it comes exactly there. Then see, I'm going to just draw a circle to make the circle as a pitch circle diameter. Yesterday we discussed, right? So just from here, make the circle. And this circle diameter, we know that this circle diameter also, we know that it is 56 radius. That means I'm going to make this radius as 56, right? We just created it. And this radius is 56. Now this point has to lie on this radius, right? So at the same time, this sketch is not fully constrained. See, this pitch circle diameter is flying in space. So select this circle and ensure that this pitch circle diameter and this one are constrained, concentric. So that first you pitch circle diameter is fully constrained. And now you select this particular point and this particular axis and select this one and make it as concentricity. And just give it okay. Sorry, not concentricity, coincide, sorry. This control is it. And select this one and make it coincide. That means it comes and sits exactly on this one. So the algorithm, yeah, you understand the algorithm of the hole. The moment I just created, the point is created. The moment I just draw the circle, default it has taken as a construction. It was not solid, right? It was taken default into a construction. That means this pitch circle diameter for the hole has to be a construction element. That's the reason the algorithm of CATIA V5, the moment you just draw the point and draw the circle, it was in a dotted line. You can observe it. The moment you just go there and you create this dimension. So here the dimension for me is that as per the specification, it is 5 mm, and depth you understand until last, right? Until last. We understood this one. And go to the type, and here we have contour bone. This is what the component. And here the dimension is 8 mm for a depth of 4 mm. And apply it, sorry, preview it. You just see that you have just created your groove as well. That means, sorry, the hole as well. So now our objective in this case is that I would like to create a n number of grooves on that one, right? I have created only one hole. I have to create more number of holes as per the drawing, 4 more. So I'm going to use a transformation feature in this case. That this transformation feature, just see this, I'm going to use a circular transformation feature. So I'm going to select my circular transformation feature. The moment I select it, it asks for a reference element. It asks for the reference. It's called circular pattern. The reference element is what? This particular face. And my current solid is taken the entire part body, including shaft, edge fillet, groove, hole, everything. But my objective currently is not my current solid. My current solid is nothing but this hole. You select that hole. I'll repeat once again how to use this one. Go and click on circular pattern, The moment you click on circular pattern, you can see a reference element. I'm going to select this my reference element, with which I would like to make my crowning definition of my circular pattern, and which is my solid, which I would like to pattern it. My current solid is nothing but this hole, just pattern with reference to that one. So now you just see this one, you're going to just change the dimension, how much you would like to have it. In this case, you would like to have 4 more at a degree of 90 degrees. So this is my requirement, right? And just give OK, you get this one. So now you have done your model as well as per the specification. So if you see the drawing, right, as per the drawing, we have just understood how to read a drawing first, right? We understood how to read a drawing, how we made the decision of making a circular shaft. So we decided the profile, right? And then we did this hole, which is nothing but at a distance of 7 mm from the top face. And then we decided, okay, let's go and create 4 holes of the dimension 8, 4 and 5 mm, the counter to the bore, and we created this one. Now if you see this point of design, let's go to this part model. At any point of time, you would like to change the hole position, right? This hole position is currently 7 mm. How to measure this distance? Yesterday we understood, right? So let's go there and understand how to measure the distance between this one. So let's go there. Where is my measure? Measure. I'm going to measure the distance between this axis and this one. And this distance is 7 mm. Just see this one. Now, what I'm going to do in this case, just see this. I'm going to just change my plane position. This is my plane, right? Just go there and change it. The moment I change my plane position from 7 mm to, say for example, 10 mm, it moves down, right? Your whole position also moves up, moves down. And you see that this measure is asking for update. Right click, you're going to learn something new thing. It's asking for local update. So just the moment you just create a local update, it gets created. So just go there and create a local update. The moment you create a local update, you get this one. So this is the process of design. So that is the reason for me to select this plane. So at any point of time, you want to modify this plane position 5 mm, you can just see that and go there and do a local update. Okay, so that's a possible. So this is my possibility. And now I would like to hide these planes. So this, I would like to hide these planes, and I would like to hide even this one, and I would like to give a material property for this one. So let's go and give the material property. Go to metal, and I'm going to use the nickel for this one. Just drag and drop on this component. Just drag and drop on this component. So that the material property is given, applied, give OK. To view the material property, just understand that I'm going to give this shading with materials. So now this component is done with shading with materials. So that's the property which you need to understand. So that means what we understand by this process, in this case, we understand how to use a shaft effectively, the purpose of groove, and how we use the reference element. Reference element is nothing but your point, lines and planes, right? Your point, the plane which we created, this plane, which I would like to give some color, this pink color plane. And then we understood how to give your whole position and how the position in sketch and your, what we call, the pitch circle diameter as a construction element also taken care, right? So the moment you want to change this one, just change the dimension to 50 or 58, just to move it. The whole position also moves it. So that's the point. So that pitch circle diameter, we use it and followed with a circular pattern. And any modification you would like to do it, you can do with reference to these planes as well. So this is what you need to understand in terms of the design aspects. Okay. Any doubts so far, please, gentlemen? Thank you.